Hello, ladies and gentlemen. Right now we're learning about the atmosphere, and we've taken some notes on the amount of oxygen in the atmosphere. That's about 21%, with the rest of the atmosphere being 78% nitrogen, 1% mixture of other stuff, including carbon dioxide, neon, and things like that. Okay. So the question is, can we prove that it's actually 21% oxygen? We're so used to breathing all the time, we don't realize that 78% is basically coming in and out. That nitrogen just goes in and out. It doesn't do anything. It's the 21% that's keeping us alive. But how do we know it's 21%? Well, we know a few things. First, nitrogen is a gas that is known as being inert. In other words, it doesn't react with things. It doesn't get electrified easily, it doesn't burn. Oxygen, however, does burn. Oxygen is flammable. Fire needs oxygen to burn, right? So let's start with a little birthday candle. And I'm going to set it on fire. And that's going to start burning up a few things. But what I'm going to do is I'm going to melt a little bit of wax and set my birthday candle here on a petri dish. So now I've got a little bit of fire. And for the moment while I'm talking, I'm going to go ahead and blow that out. And the other thing I have right here is I have a beaker, and I'm going to fill it with some water. It's actually, the beaker's already full. I'm filling a petri dish that's holding the candle with water. Okay? Now, I'm going to use a test tube and I'm going to gather a sample of atmosphere. Scoop. Doesn't really matter. I'm just going to scoop up some atmosphere. It's good to go. Scoopy, scoopy, scoopy. Doesn't really matter. Okay? And now, if I seal this off and then burn off all of the oxygen inside the sealed test tube, then only 21% of it should actually burn. And if we can measure the amount that burns off and the amount that's left off, then we can figure out, oh yeah, guess the atmosphere really is made of the amount of oxygen. All the textbooks say so. So how do I do that? Well, how do I seal off this test tube? Well, if I set it over the candle so that the rim goes over the water, okay, then it's going to be holding the atmosphere, and the air can't get out or new air can't get in because the water's in the way. And we can burn it off if we have a candle lit ahead of time. Pretty good idea. Let's see if this is going to work. Oh, look at that. What happened inside the test tube? Why is the water all of a sudden starting to fill up part of the test tube? Well, the atmosphere burned. So the oxygen in the atmosphere it burned away. It was taking up space. Well, the test tube didn't get any smaller, so something has to fill that space. The only thing available was the other fluid, water. What we can do is we can move this little rubber band that I was so smart to put onto my test tube ahead of time right to the water level so I can mark how much of the test tube has been filled with water, aka how much of the test tube used to be filled with oxygen. Pull that off, and now I have a mark. This much was oxygen, this much was nitrogen. Looks pretty close to 21%. We'll see how close it is. Well, we'll start by, we're going to put the candle inside the test tube. Why did I put the candle inside the test tube? Well, wasn't the candle always inside the test tube? So yeah, it was taking up space in the test tube, and we don't want to forget that. So we don't want to be off based on the measurement of the volume of a candle. And since I can't see the air, what I can see is I can see water. And so what I did is I filled up my test tube with water, and now I can measure this much water versus this much water to figure out what percentage is oxygen. So I'm going to start by very carefully pouring this into my graduated cylinder. Need a couple more drops. Ooh, pretty good. What do you think? Pretty good. Hey, and I'm going to look really closely here. Okay. And I'm going to type into my calculator 17 milliliters. 17 milliliters. Okay? So 17 milliliters. And now, if I'm very carefully, I can remove my candle. I'm going to set it right there so I don't lose it. Okay? And I'm going to pour the rest of the water, which represents the rest of my atmosphere, into my test tube. Okay. And I have 77 milliliters. So I've got my 17 already in there, divided by the total atmosphere, 77 milliliters, equals, ooh, pretty darn close. Look at that. 22, oh, we should multiply by 100 times 100 so that I can get the actual percentage rather than the decimal place. Okay. 22%. And I'm just measuring with simple middle school tools, and I got 22% oxygen. That's pretty darn good if the average for the atmosphere is 21%, only off by 1%. It's a tiny little bit, and quite honestly, I could have spilled a little bit. There's a few drops of water here on the table. There were a few bubbles in my test tube. Quite honestly, it might be fairly accurate that I had about 21%. So I'm going to repeat this experiment a few more times just to make sure, but I think we've seen that the atmosphere seems to be approximately 21% oxygen. 78% nitrogen would be the rest, plus that 1% of various other things. And that also might be throwing us off because some of those might be flammable too. But quite honestly, right around 21% is a darn good calculation. I think we've demonstrated atmosphere is 21% oxygen. Have a great day, everybody.